Hello everyone, this is Dr. Manali Datta. Hope all of you are doing very well. Welcome to my channel Chemistry with Manali. So in the previous 3 videos we have discussed about valency of elements, electronic configuration and the formation of compounds. So today we will be starting with another topic, organic compounds. So this part of chemistry will require a basic understanding of electronic configuration of and valencies. So please go through the previous videos and the links will be provided in the comment section. So this part forms a very vital branch of chemistry. So let us try to understand what are organic compounds. So the compounds which contain carbon as the essential element are known as organic compounds. So this part of chemistry forms a very core branch of chemistry, that is organic chemistry. Now, one most important criteria of organic compounds is that they form covalent bonds. That is, the compounds formed by this kind of compounds always exhibit equal sharing of electrons between the elements. Now, let us try to understand the essential criteria of these kinds of compounds. Number 1, it is these kinds of compounds are tetravalent. That means we already know that carbon always shows a valency of 4. So in our organic compounds also carbon will always exhibit a valency of 4. So this is how the compounds are arranged. That means this is 1, 2, 3, 4. So carbon always forms 4 covalent bonds and so it exhibits tetravalency. Next, catenation. So this is another very important characteristic of carbon compounds. So catenation means carbon always has a tendency to link with other carbon atoms in chains. So this is how carbon will link with other carbon atoms, and this property is called catenation or self linkage. But one important thing to keep in mind is that carbon will always show valency of 4. For example, this carbon, it has a valency of 4, 1, 2, 3, 4. For this also similarly 1, 2, 3, 4. And similarly for all other carbons, valency will always be 4. Now this self-linkage of carbon atoms can be of various types. Number 1, carbon can link with other carbon atoms in straight chains. This is one pattern by which the self-linkages are possible. Next, carbon can link with other carbon atoms in branched form. That means here it can form another branch, but the only thing to keep in mind is the valency of carbon will be 4. Here it can link with other carbon atom in the form of branch. Similarly, again here it can link with other carbon atom in the form of branch. So you can see that here carbon is linking with all carbon atoms, but they are forming branch. Here there is one branch, here there is one branch, again here there is another branch. Next one, carbon can link with other carbon atoms in cyclic form or closed structure. For example, this, it is forming linkage with other carbon atoms in a closed structure or cyclic form. But again, one thing to keep in mind is it will form a valency of 4. This carbon, it has a valency of 2, 1, 2. So it will form bonds with other 2 atoms. For this carbon similarly, for this also 4. So you can see that in all the types of patterns that I have shown, carbon is always exhibiting a valency of 4. Again, so these are the 3 types of self-linkages that carbon can form via single bonds, either in straight chain, in branch chain or closed or cyclic form. Again, the linkages can be formed via double bonds. For example, this. Here carbon is linking with other carbon atom by forming double bonds, but the valency remains the same, 1, 2, 3, 4. Again, carbon may link via triple bonds. For this carbon the valency is 1, 2, 3, 4. For this also it is the same. So catenation may be possible in various ways. Firstly, it can form linkages in straight chain. It can form linkages in branch chain. It can form linkages in closed or cyclic form. it can form linkages through double bond, it can form linkages through triple bond. So these are the various possibilities through which carbon can link with other carbon atoms. Now let us discuss the types of organic compounds. So organic compounds may be of the following types. Hydrocarbons. Hydrocarbons means the compounds will contain hydrogen and carbon. So hydrocarbons are, for example, alkanes, alkenes, alkynes. So alkenes will contain a single bond between the carbon atoms. Alkenes will contain a double bond between the carbon atoms, and alkynes will contain a triple bond between the carbon atoms. Now alcohols. So alcohols, their general formula is denoted by OH. So any compound which we identify as an alcohol will essentially contain this group OH. For aldehydes, they will contain this group CHO. So whenever you see any compound which contains this group CHO, you can easily identify it as an aldehyde. Ketone, the functional group is CO. CO. So any compound which contains CO can be identified as a ketone. For carboxylic acid, it is COOH. For ether, it is, that means ROR. This R may be any group, and this is essentially this O group identifies any molecule as an ether. So these are the types of organic compounds that are available. So hydrocarbons, these may be of three types: alkanes, alkenes and alkynes. Alcohols, they are identified by this group OH. Aldehydes will be identified by this group CHO. Ketones by this group, carboxylic acids by COOH, and ether by ROR. Now let us try to understand the next topic, which is types of hydrocarbons. Now let us try to understand the types of hydrocarbons. So hydrocarbons may be classified in the following way. It may be either classified as aliphatic or open chain, or cyclic and or closed chain. So aliphatic or open chain, these are the compounds which are not closed, they are open chain. For example, this is an aliphatic or open chain hydrocarbon. Cyclic or closed chain, this is, for example, this is a cyclic or closed chain compound. Here the carbon atoms are linked to each other in a closed structure, and here the carbon atoms are linked to each other in an open chain form. Now this aliphatic or open chain hydrocarbon may again be of two types: saturated and unsaturated. Saturated means where the carbon atoms are connected to each other through single bonds. They are called alkanes. And unsaturated means the carbon atoms are connected to each other by multiple bonds. Multiple bonds means it may either be double bond or triple bond. For example, in case of alkenes, the carbon atoms are linked to each other through double bonds, and in case of alkynes, the carbon atoms are linked to each other through triple bonds. So saturated means single bond between carbon atoms, and unsaturated means multiple bonds between carbon atoms. So alkenes means double bond and alkynes means triple bond. Now here the cyclic or closed chain may again be of two types: alicyclic or aromatic. Alicyclic means carbon atoms may link to each other, to form a closed chain. And in case of aromatic compounds will contain benzene as an essential part, and they will contain an alternative single or double bond. For example, this is an aromatic compound. Here these are all carbon. Here the carbon atoms are linked to each other in a closed chain. It contains benzene as the essential molecule, and the bonds between the carbon atoms are arranged in alternate single and double bond fashion. For example, again This is again an aromatic compound. This cannot be identified as an alicyclic compound because here it contains benzene, two benzene molecules fused to one another, and they will contain alternate single and double bonds. This is one double bond, the next alternate is here, next here, and here also there are alternate double bonds. So this is an aromatic compound, it is not an alicyclic compound. So this gives you a basic understanding of the types of hydrocarbons or the types of organic compounds that are present. So in the upcoming video we will discuss homologous series, functional groups, and how to write the formula or structure of these organic compounds. Okay, thank you all. I hope you like this video, and if you found this video informative, please like and share my videos and subscribe to my channel.